Finally, I have my hands on a Ryzen 5000 series CPU and an RTX 3000 series GPU. So this video is about putting them together in a system, showing you how to build it and showing you the performance, and talking about maybe some things that you might want to switch out, as the setup I've gone with, well, it's a bit over the top. Either way, let's get started. But first, a message from this video sponsor, ASROCK. Their brand new B550 Taichi Razor Edition sports Razor Chroma RGB lighting, both on the board and via standard and addressable headers, alongside support for AMD's Ryzen 5000 series CPUs, an optimized and powerful VRM design for even the highest end chips, and killer E3100 2.5GB LAN, as well as AX1650 Wi-Fi 6 on board. Find out more at the link in the description below. Now, starting off with the parts, we're going to be using a Ryzen 5900X. This is a killer 12-core CPU. It's probably more expensive than it should be, and you might want to shop around perhaps for a 3900X instead if you want to, although we'll talk about the things you can change about the build in a second. Either way, it's incredibly fast for both productivity and for gaming as well, whether you even want to game at 1080p, more reasonably at 1440p, or even at 4K if you want to. As for the graphics card, this is an RTX 3070. Now, I know I made a video saying don't buy a 3070, and the majority of my point there is hold off until the pricing is, kind of reasonable. But if you are dead set on building this, or you just want to use this video as a reference for 6 months' time when, stock and pricing is back to normal, a 3070 is still a very impressive card, and especially from last generation, is actually not too bad of a value for money. Now, the card I've got is the only one that I could get my hands on. I asked everybody, but the one that I have is a ZOTAC Twin Edge. It's the non-OC version, so you can expect a bit better performance if you were to go with the OC version or a different model or brand entirely. As to the motherboard, we're going to be using the one that you probably just saw, at least unless you're a patron, which is the ASROCK B550 Taichi Steel Legend. This is an incredibly impressive board. The VRMs are overbuilt AF, and it has some extra RGB lighting if you're into that. As for the RAM, we have 32 gigs of Corsair Vengeance Pro RGB memory, and this specific kit is 3000 MHz, although I would recommend 3600 for pretty much any Ryzen build. So if you're getting that, that's what I'd get, but that's what I have on hand. Storage is taken care of by two M.2 SSDs. One of them is a Sabrent Rocket 4, which is their PCIe Gen 4 drive. It's overkill for what we need here, but why not, right? So that's what I'm using, and I've also got an even more overkill drive for sort of secondary storage, which is the Sabrent Rocket Q, 4 TB. And then the cooler is an H100i Elite X. The case is a Phanteks P360A, which is something that I just generally like. Phanteks cases. They're generally pretty easy to build in and stylish. Good enough quality, and this one's only like £65, so awesome. And the power supply is a Corsair CX750F. So that's the parts. Let's get to building. The first thing you want to do is get your motherboard out and install the CPU. This is really simple. Align the small Go triangle on the CPU with the triangle that's on the socket, lift the arm up, place it down gently in. It should drop into place without any pressure. Push the arm down, and that's your CPU installed. You want to do the memory as well. Open the locking tabs. On this motherboard, we only have tabs on the top, so crack them all open, align the notch that's in the memory with the notch that's in the slot, and place them in, making sure that you hear a click from both sides. Repeat for the next 4 DIMMs, and you're good to go. And next we'll want to install our M.2 SSDs. Now, because the Gen 4 drive comes with a massive heatsink, we're going to use that instead of the relatively small one that comes on the motherboard, although if it doesn't come with a heatsink for you, the motherboard one is plenty fine. Either way, we're going to use the included screwdriver that comes in the motherboard's box to remove the 2 screws that hold the top cover in. We're going to install the little standoff that holds the SSD up, place the SSD in an angle, aligning the notch, flatten it down and put the screw in the back that holds it in place, and then we're good to go. You will also want to install our second M.2, which is going to be in the bottom slot, and this one, again, 2 Torx screws that need to come out with the included screwdriver. Again, a little standoff goes in, and then we can place the SSD in at an angle, slide it down so it's flat, and insert it all the way, screw in the back, and then we can put the heatsink back on, making sure to remove any sort of protective material on the thermal pad first. Right, so that's our motherboard pretty much set up, so let's put that to one side and get the case ready. We want to take both side panels off. That makes things way easier to deal with. And then we're going to find the box or bag of screws that you need to install all of the parts, and we're going to install the power supply. You want to put this fan down as the case has a dust filter on the bottom, and there's also not exactly much ventilation from the power supply shroud that's on there anyway, so fan down. Slide it in from the back and push it up to the sort of mating surface, 4 screws in the back, and we're good to go. Now the case comes with all of the standoffs pre-installed that we need, so we can now install the motherboard. You want to drop it in at a slight angle so that the rear I/O shield goes in a little bit before the sort of right hand of the motherboard. Place it down in, making sure that the I/O shield matches the hole in the back of the case. And then once it's in place, the central standoffs have a little lip on them that the motherboard can basically hang on. So while I'd recommend you do this with the case lying down anyway, if you are doing it upright, you'll feel it latch into place, and then you can put the 9 screws that hold the motherboard in sort of rows of 3. It's a column of 3 and rows of 3 gridways. You'll see where they are. Next, since there's not much space between where we're going to mount the cooler and the motherboard, we're going to pre-route all of our power supply cables and connect them up. Now, you will want to make sure if you have a fully modular power supply like that one to connect all the cables before you put them in the case, but even if you do put the power supply in without any cables attached, it's still relatively easy to connect them. It's just a little bit of a quality of life improvement. Either way, once all of your cables are connected, you will need an 8-pin for your CPU, you'll need 8 pins for the GPUs, those are different cables and connectors, you need 24-pin for the motherboard, and you'll probably need SATA power connectors for the case, cooler, and any hard drives if you're adding them in. Once you've got all of your cables, you can then go and route them around the case. The 8-pin goes up at the top left of the motherboard, so you want to route that around the back and up at the hole at the top, and then connect it to one of the 2 8-pins that are there. A quick note, you may look at this board and see 2 8-pins and think you need to connect them both, but you don't. Most of these 8-pins can handle 300 watts of power, and even the 5950X is only going to draw about 130 to 140 watts, so it's really not a problem unless you're, LN2 overclocking, but you wouldn't be doing that in a case for your, first time building or whatever, so don't worry about it. You also want to connect up the 24-pin, which is on the sort of upper right side. You want to route the graphics card's power connectors, the PCIe power, through the small hole that's in the floor, and then route any SATA power cables to where they need to go for case or for the cooler in a second. Once all of those are connected up, especially the 8-pin power connector up at the top left, as that's going to be the one that's the hardest to fit later, we can then install the cooler. I'm going to have it at the top of the case, and I'm going to have the tubing towards the front of the case so that it sort of snakes up nice and evenly. Once that's screwed in, there's 8 screws at the top and you'll need to remove the nice magnetic dust filter. You can then install the pump head to the CPU. In my case, I'm going to need to throw on some thermal paste, so a small pea size or grain of rice size amount is plenty. And then you'll want to attach the AMD mounting brackets to the cooler if you haven't already. Those just press onto the side, and they use the existing mounting points on the brackets that come on the motherboard, so it's pretty simple. All you do is just place it on, hook the 2 clips over, and tighten it down. Then we can get onto the absolute mess of wiring. The cooler comes with a Commander Pro control unit that you want to connect the long, thick cable from the CPU block itself, as well as SATA power. You'll also want to connect up all of the fans to that, both the RGB headers and the fan headers, and then it will pretty much all work fairly seamlessly, and also connect up the USB cable to one of the 2 USB 2 ports down at the bottom of the motherboard. You will also want to connect up all the other front panel headers like the HD audio in the bottom left, the front panel headers for your power button and reset down at the bottom right, and the USB 3 header up just below the 24-pin. Once that's done, we can then think about installing the graphics card. We'll need to remove the blanking plates that are on the back of the case, both the one that's in line with the top PCIe slot, as that's the one we want to install it in, and the one below it, as it's a dual slot card. Once those are out, you can then press the locking tab that's on the slot down, offer the card up so that it's lined up, push it into place until you hear a click from the locking tab, put our 2 screws in the back in, and then connect up our power supply cables, and we're all set. So that's how to build the system, but what about how it performs? Well, let me go install Windows on this, get some games loaded up, and then we'll have a look. Now, starting off with Battlefield 5, this is tested at ultra settings and with DirectX 12 enabled. Now, of course, all of these tests are run at all three resolutions, 1080p, 1440p, and 4K. And at 1080p, we're getting a pretty reasonable 164 FPS average. Of course, you can turn the settings down a bit if you want to run, say, a 240Hz monitor, or if you want to run 1440p at, say, 165Hz, then you can turn it down ever so slightly. Of course, it is an RTX card, so you can turn on RTX if you want, although you will be significantly reducing your frame rate, even with this newer 3000 series card. COD Modern Warfare is pretty similar. In fact, it almost always basically matches Battlefield 5 in terms of its performance, and really impressively, it's still getting over 70 FPS at 4K. At ultra settings, it's 75 average and still a very good 1% low of 58 as well. Otherwise, it's 170 for 1080p and 124 for 1440p, so a very good playing experience. Fortnite is one of the ones where no matter how many times I run a benchmark, even using replays, the FPS average that you get out of it is almost always variable. Depending on the millisecond that you press the record button, it does vary a hell of a lot, so you will find a pretty big mix of performance here. At 1080p, it was over 200 FPS, 1440p, it was 132, and you're still getting over 60 FPS at 4K. As for Watch Dogs Legion, this is the canned benchmark, and honestly, Watch Dogs is an incredibly hard game to run, even forgetting any of the ray tracing DLSS features. Either way, at 1080p on ultra settings with their canned benchmark, it was 76 FPS average at 1080p, 62 at 1440p, and 38 at 4K. That isn't quite the FPS that you get while playing, and I would generally recommend pulling the settings down, but either way, that's what you get. As for Cinebench R20 and the more CPU-bound workloads, it does a really good job. It beats out pretty much anything other than the 3950X and the 5950X, so great job there. And Cinebench R23 is, I guess, even more impressive since the numbers are just even bigger. But yeah, it does a great job. You have more than enough rendering power here. And actually, even in programs like Blender, where we're doing more, I suppose, real-world renders, testing with the Blender BMW test scene, it took 1 minute and 51 seconds to render. For context, a 3900X would take about 2 minutes and 2 seconds, so a reasonable improvement. As for my 10-minute Premiere test render, that took just 3 minutes and 29 seconds on CPU only. That's not using any CUDA or acceleration, graphics card acceleration. So again, you have plenty of productivity power. So as you would expect, this is a powerhouse of a system. You get plenty enough performance at 1080p, 1440p, and even 4K if you really want, and you have plenty of CPU horsepower if you want some more productivity-based apps, and especially if you're buying a 12-core CPU, you probably want to do some productivity on the side, whether that's streaming and gaming, whether that's editing videos or photos, or even 3D modeling, game development. Anything that's CPU intensive, you have more than enough power to do that with this build. And in terms of things that you can change, well, there's quite a lot. If you want to tailor this build to be more of a gaming-focused system, then you can drop the CPU down all the way to 5600X. You'll still get pretty much the same gaming experience, but you'll save a butt ton of money, and you might actually be able to afford a 3080 instead if the budget allows. You also don't need an all SSD setup, and you certainly don't need a 4TB M.2 or a Gen 4 M.2 either. So if you want to go with a more reasonable M.2 drive, say a 1TB Western Digital SN550 drive, and go with a 2 or 4TB hard drive instead, well, that's going to save you a whole lot of money as well. You can also go with a cheaper, more value-oriented motherboard. ASROCK's B550 Steel Legend is a lot cheaper, but still runs plenty fine, so that's a good option. Or you can even go with one of the even more budget ones, X570 if you prefer. There's a lot of options there that can either save you money or give you a different feature set if you'd prefer. Of course, graphics card choice, at least when this video is going up, will be more determined by what stock is available and how much money you're willing to spend, and if you're willing to pay the sort of inflated prices that are currently out for any of the new cards. If this is something that you're going to build in a couple months' time, then that will be subject to change, so feel free to keep an eye on all of the links that are in the description for local pricing when and where you watch this. But either way, you know, I'm going to leave that one up to you. And cooler, you can obviously switch out for an air cooler if you prefer. Even a sort of Arctic Freezer 50 is going to be plenty fine for this sort of CPU. Or if you want to go liquid cooler, there are a number of other options as well. The case is very nice to build in, it's very easy and is a really nice quality. But of course you can pick whatever you want stylistically. If you want to go with a white one or just a different brand, Lian Li is pretty popular as well. Feel free to pick what you want. And the power supply is kind of up to you. I'd recommend 600 to 700 watts for a 3070, ranging more to the 750 watt side of things, as they have fairly high current spikes, especially when you like load up games, your system can just straight up turn off. So that is the build, that is the parts, how to build it, the performance, and things that you could change about it to make it a bit more suitable to you, as this is, well, it's a little bit overkill in a couple of areas. Either way, that is pretty much it from me. Like I said, feel free to check out the links in the description down below. They are affiliate links that will take you to the local Amazon store. We can see pricing when and where you watch this, because it can and does vary. There's also a whole load of other links in the description you can check out for Patreon if you want to see sponsor-free videos like this one, or if you're not a patron, feel free to check out the sponsor, and feel free to check out stuff like merch, hoodies, t-shirts like this one, and a load of other videos over there too. Of course, if you haven't already, consider subscribing for more videos like this one on a Monday, Wednesday, and Friday basis. And otherwise, thanks for watching, hope you enjoyed it. If you've got any questions, leave those in the comments down below. We'll see you on the next video.